Okay, so today we're looking at parallel perpendicular lines. Really isn't too bad if you did well a couple days, the previous 2 days. So math isn't changing, there's just one new concept, which is that, or I guess 2 new concepts that are linked together. So we say parallel lines have the same slope. This is important. So anytime it asks you for an equation slope-intercept form for a line parallel to some other line, all that's telling us is that we know our new line has to have the exact same slope. So if it tells us y equals negative 6x minus 3, our new line is also going to have a slope of negative 6. Okay? So all we need now to get our equation slope-intercept form is we just need to know what is the y-intercept of a line with a slope of negative 6 and it goes to the point 1, negative 5. So since we have a point and a slope, we can use point-slope form. So same as before. So y minus y1 equals mx minus x1. Hopefully you've committed that to memory because you've seen it enough times. So we fill in our values. So y minus negative 5 is the same as y plus 5. M we said was negative 6. That came from our original line. And then x minus 1. Okay, it's the same 3 steps for solving point slope. First, substitute the numbers. Then we're going to distribute. I wanted a different color. There it is. So y plus 5 equals negative 6x. Negative 6 times negative 1 is positive 6. And then our third step is always just to get y by itself. So we bring the 5 over. Oh my goodness, I hate this board. Come on, change my color. Give me a different color. What do I do with the pen? There it is. Okay, minus 5. So that's going to cancel, so we're left with y equals negative 6x. Let's see, 6 minus 5 is 1. So here is our new equation. Okay? So that's how we do it mathematically. If for whatever reason you wanted to do this as a graph instead, because you haven't graphed stuff in a while. So if we graph our original line, so I started from the y-intercept that it gave us, the minus 3. Our slope was negative 6, so I went up 6, back 1. And then we plot out our additional point. We said that point was 1, negative 5 here. So there it is. So I know my new line is going to have the same slope as that, so it's also going to be negative 6 over 1. So from there, I could just count 1, 2, 3, 4, 5, 6 up, 1 over. I don't even need to do anything else because there's my intercept. If I connected them though, just for fun, we would see, well, would see if I graphed it properly. Come on, close enough. You can see those lines running parallel to each other. Okay, there you go, halfway there. But what about, let's erase this line. What if I wanted the line perpendicular to that? So perpendicular just means 2 lines that meet at a right angle. So I know for certain if this one's going downhill, to make a right angle, my other line would have to be going uphill. Okay? So we know it's going to be the opposite sign. So I know it's positive something. And then when we make a perpendicular line, the more steep the original was, the less steep the new line is going to be. So how we show that mathematically is we take the reciprocal. So if our original slope was negative 6 over 1, our new slope is going to be positive 1 over 6. Okay? And I know this isn't the actual question, but just because we have the graph here. So we would say if we pick the same critical point, we go up 1, 1, 2, 3, 4, 5, 6. And then if I were to draw this line perfectly, we could say that this is definitely a right angle here. Okay? we can go back to our notes and explain what that means. Perpendicular lines. Say they have slopes that are, and I think some of these books call it opposite reciprocal, but I still like saying reverse reciprocal. It's got that alliteration to it. Reciprocal. Soles, plural. Okay. So all that means, we're going to do the same ideas what we did with parallel lines, only we can't just take the slope as given to us. So we have to flip it over, and we need the opposite sign. So 9/5 is going to become negative 5 over 9. So that's all we have to do. That's the only part that's really new here. If it's perpendicular, you take whatever slope it gives you, flip it over, change the sign. Negatives become positive, positives become negatives. Past that, then it's just back to making an equation. So we do point slope again. It's our very best friend. So y minus y1 equals mx minus x1. Fill in our values. I know this seems bad because it's 5/9, but it's going to work out, I promise. So y minus 5 equals negative 5/9 x minus also 5. Okay, so we substitute first, then we distribute. So y minus 5 equals negative 5/9 x. Wait, that doesn't work out nicely. Ugh. Yo, I don't like this question anymore. All right, well, we'll go with it anyway. So this is going to be 25/9. Oh, that's gross. Why is this a question? I should have proofed this first. Okay. Unless I messed up, which case I'm going to have to redo this whole thing. So let's just add 5 anyway. Let's just finish up while we're here. Last step, we always get y by itself. So y is going to equal negative 5/9 x plus, all right, what's that going to be? So 5 would be, if we want that as something over 9, so 9 times 5 is 45. So 25/9 plus 45/9 is 70/9, which is not an amazing number. I'm not going to lie to you, but that will give us an equation. I guess that is a good thing to point out, and why point slope is so effective, because if you tried to do this graphically, right, you would cross the y-axis somewhere between 7 and 8, but you wouldn't have an exact answer because this is some terrible decimal value. But if you do point slope, even if you get a non-integer value, you can still have an exact answer. Okay, so I would definitely recommend using point slope form. If for no other reason, it makes your work look really impressive. You show this to somebody and it makes it seem like you know math. Okay. Other than that, we're answering questions, but they're multiple choice, so the same shortcuts apply. Like if this one says parallel, we know the slope is going to be -4. So we can eliminate any answer that doesn't start with y equals -4x. And for some of these, it eliminates all but one answer, so that's nice. If you get one, there was one on here, because the special case, here we go. Parallel to y equals 1. So if we think about this one here, where y equals 1, what kind of line is that? So anywhere, any value of x, y always equals -1, right? Anywhere on this line. So that is a horizontal line, right? And if it's parallel to that, it's going to be another horizontal line. So it's also going to be y equals, but it has to go through this point, -4. So the only line that's horizontal and goes through -2, -4. Oh, come on. You can do this. There it is. It would have to be somewhere down here. So y would have to equal -4. There you go. There's a free answer. If we said perpendicular to that, why not? Because you can't really do slope with this, or we can't do reverse reciprocal, because the reverse reciprocal of a slope of 0 would still be 0. But the line perpendicular to a horizontal line is actually a vertical line. So if this said, for some reason, goes through -2, -4, and is perpendicular to that line, instead of y equals something, you would have x equals something, and then in this case it would have been -2. So there's your special case. If it's parallel to either y equals something or x equals something, you're just going to look at that value. In this case, we looked at the y, and then that's your answer. If it's perpendicular, y equals something will switch to x equals something, and then vice versa. If it said what's perpendicular to x equals -2, you would say, well, it's got to be y equals something. Hopefully that makes sense. Do the practice, and then I'm sure as you see it, it'll make more sense than just listening to me try to explain it. I hope.